Okay, let's start here on question 22. Question 22 is another doozy of a problem here. We're going to look at that f of x plus h stuff. Now remember, they're going to give you the difference quotient right here in the problem, and it kind of tells you the three steps. The first step is the f of x plus h, then you're going to subtract the f of x, and then you're going to divide by h. So first, let's do the f of x plus h. That's our first step. And that will be tough here because you have to plug it in multiple times. And this is not going to be the most beautiful thing we do today. Okay, this is the tricky part. Remember, x plus h times x plus h, that's x squared, plus xh plus xh, that's 2xh plus h squared. So don't forget the negative 7. That's an x squared plus 2xh plus h squared. And then I got to distribute this, plus 4x plus 4h plus 7. A little more distributing, and then we'll be done. There won't be any like terms. Negative 7x squared minus 14xh minus 7h squared plus 4x plus 4h plus 7. The second step is to subtract the f of x, and every single thing will cross out with something here. So when I subtract a negative 7, that's the same thing as adding the 7x squared, so that's gone. Subtract the 4x instead of add it because you changed the sign, and subtract the 7. So I subtract the f of x. All I have left is negative 14xh minus 7h squared. A lot of kids had sign mistakes on the first test, and I think it's probably from not distributing correctly. And our last thing is to divide by h. When we divide by h, each piece is going to cross out one of the h's. So those h's will cancel for the first one, which is a negative 14x. Here, you still have the minus. Only one of the h's will simplify, so it's a minus a 7h. Here, the h's both will simplify, and that's a plus 4. So that's my answer. Negative 14x minus 7h plus 4. Okay, what do we do on these? We just need to look at our graphs closely. The domain of f is left to right, and we're using those x values. So we're looking from 3 to 13. Square brackets for everybody because it can be 3 and it can be 13. When you look at the domain of G, G is starting over a little bit further. It's starting at 2 and only going to 12. So when you add them, you can only add them in the places that they have in common. So you kind of have to find the smallest commonality here, and that's going to be from here to here. So it's going to be from the 3, and then it's going to go only to the 12 because that's where the second function ends. Okay, if I'm going to add them, oh, now this is another question, I guess. This is a subtraction question. I can go ahead and do this too. They want us to take the G graph, which is the green one, and subtract the F graph. You can only do it where they have in common. So right here, they're going to start at 2, and it's kind of hard to tell, but only the graphs that start at 2 could be right. This one's starting at 3, so that's out. And I think this one is also starting at 3, so that's out. So I'm going to take the G value here, which is 4, and then I'm going to minus the blue value of F, which is 1. 4 minus 1, 4 minus, excuse me, it's a negative 1. 4 minus negative 1 will be 5. So on that 2 spot, it's going to start at 5, which means my answer is going to be D. You only have to do one check to find the first starting point. Okay, here's a word problem. This is not hard. Profit is revenue minus the costs. So if this is the revenue and this is the cost, they want us to find the profit. So we're just going to take the revenue, which is 60x, minus 0.4x squared, and we're going to subtract the cost. But when you do that, you must have parentheses. You will have to subtract all the pieces. So that's 60x minus 0.4x squared minus 4x minus 13. So make sure you subtract all the pieces. They want us to put it in the right order with the x's first. So that's going to be a negative 0.4x squared. Now I'm going to do the x's. I have a 60x minus a 4x, so that's plus 56x minus the 13. Okay, so they want to know what the revenue is for $100. We'll go to function R and plug in 100. So that's just 60 times 100 minus 0.4 times 100 squared. So I'm just going to type that in my calculator. I'm not switching over because it takes me a little bit long to do that. But 60 times 100 equals minus 0.4 parentheses 100 squared. And I get 2,000 after I type that in my calculator. They want the C of 100, which will be a little bit easier. C of 100 takes the 100 and plugs it in for x in the C function. So it'll just be 400 plus 13, which is 413. Now, to find P of 100, you can plug 100 into this equation if you want, but P is just the R value minus the C value. So if you just take 2,000 minus the 413, that's the more direct way to do it. You will get 1587. Yes, you could type 100 into that equation as well, and you will also get the correct answer. Okay, difference quotient. There's not a formula, but you needed to remember that was called the rate of change formula. Difference quotient was the rate of change formula, which is another word for slope. If it's a line, you only need to type in the slope. Okay, I'll let you do this one on your own. All right, now the composition, and some of you did miss this on your first quiz. Okay, f of g of negative 4. That's f of g of negative 4. You write it like this first. So what we're going to do is we're going to plug negative 4 into g. We're going to get an answer, and we're going to plug that into f. So we're starting with the g of negative 4. In parentheses, that's negative 4 squared plus 2, which is 16 plus 2, which is 18. That was the first step. Now I take that answer and I plug it into f. F of 18 is 5 times 18 minus 1. Type that in my calculator and I get 89. I'll let you do that one on your own. Okay, let's try this one. H of x. This time, we're not plugging in a number, we're plugging in x, so I'm going to get x in my answer. Basically, I'm just going to plug h into itself. So that becomes h of x squared. So I'm going to take this x squared and I'm going to plug it in to where the x was before. So then it becomes an x squared squared. Take the x squared and plug it into where the x was, and then it's x squared squared, which is x to the 4th. Okay, here's more of f of g. Some of you had these backwards. You had the right answers in the wrong spot. So this time g goes into f. So it's f of the square root of 4 minus x. So this goes into the f in parentheses. square root of 4 minus x squared plus 2. So I took the g and I put it into the f. The square root and the square will cancel, and I'll get 4 minus x plus 2, which, if you put the 4 and the 2 together, you can either put a 6 minus x, or you can put a negative x plus 6. Just be careful with your signs. It doesn't really matter which way. Now, if you do g of f, this time you're plugging f into g. And you'll have to do that with parentheses because it's going to get pretty tricky here. When I take the x squared plus 2 into function g, I have 4 minus parentheses x squared plus 2. So what that does is it changes all those signs. 4 minus x squared minus 2. And it's all underneath the square root. And this time it's a 4 and a minus 2. So that's a 2 minus x squared. So it's a square root, and then you'll have the 2 minus the x squared underneath. You might want to do those a couple of times. Okay, so what is the domain? Let's clear this out here. Of f of g. That was the top one. And what can I plug in? There's no problem here, right? 6 minus x, just a line. So that's negative infinity, positive infinity. Oh, I'm a liar. You guys think that's funny? I got to erase my work. That's why. This is why. Domain of f follows g means g happens first. Then it goes into f. And g was the 4 minus x. I cannot plug anything into this machine, right? 4 minus x, the square root of it, has to be greater than equal to 0, and that's where I messed up. If you add x to both sides, 4 has to be greater than equal to x, which I can rewrite as x is less than equal to 4. So really, we can only plug in negative values into that linear equation for it to work out. So that was a Mrs. Bruno mistake. Negative infinity to 4, and it's going to get a square bracket. Okay, for the second one, g follows f. Well, there's definitely going to be some sort of issue here. So what happens first is the f function, which is x squared plus 2, and nothing will break that. But for this guy, we said 4 minus x had to be greater than equal to 0, which meant that we just wrote it down. X had to be less than equal to 4, right? But that is not directly plugged into it. This means that x squared plus 2 has to be less than equal to 4. You would subtract 2. I don't remember this being on the test. If you square root both sides, that means x has to be less than equal to the square root of 2. I don't know about that. Let's see what happens. Negative infinity to the square root of 2. And like I said, I don't remember talking about that one much with kids last year. What did I mess up now? Nothing breaks this one. This one, I can only plug in numbers less than equal to 4. So x squared plus 2 has to be less than equal to 4. Minus 2, minus 2. Square root both sides. I don't know. Let's see what they said if I go to question help. I have to go all the way to the domain. They're finding the pieces there. We did the first one. Okay, so they said x squared plus 4 has to be less than equal to 7. And what did I say? X squared plus 2 had to be less than equal to 4. That's what I had, x squared less than equal to 2. Oh, they did because it's an inequality. Huh. Yeah, okay, this is definitely not on there. They're saying that it has to be, they say negative square root of 2. Okay, what is it, brackets? Oh, I'm going to do negative square root of 2, positive square root of 2. That was a doozy. You guys won't have to do that one on the test. That's definitely not going to be on there. Okay, so that one was weird. Okay, this one's going to give us numbers back. I know it's going to give us numbers back because I'm plugging numbers in. F of g of 5. Start with the g of 5. That's 5 squared plus 5. 25 plus 5 is 30. My new problem is f of 30, which will be 2 times 30 minus 1. 60 minus 1 is 59. G of f would be the opposite way. So I'm going to do f of 5 first, which is 2 times 5 minus 1. 10 minus 1 is 9. And now my problem is g of 9. That's 9 squared plus 5, which is 81, plus 5, which is 86. Okay. This one is a different one too, actually. They wanted to know, where did you plug 6 minus 9x into? What was the function you plugged it into? Remember, if you put an x over top of the parentheses, it will tell you that you plugged it into x squared. Okay, let's look at some symmetry. I'm going to skip one here. Let's do this one. Does it have x-axis symmetry? Does it fold over the x-axis? That is a yes. Does it fold over the y-axis? That's a no. And does it have origin symmetry? If you turn it upside down, will it be the same? And that is also a no. Okay, let's skip that one. This one you would actually have to type in your graphing calculator to look at if you don't know. But the graph is the absolute value shifted down 3. So is that 180 symmetry if you flip it upside down? No. Does it have y-axis symmetry? The answer is yes. Does not have x-axis symmetry. Okay, we'll skip this one. They give you a graph. This one they actually want us to do with the test, okay? So to check these, you will plug in negative y to see if it gets the same thing. On this one, you plug in both negative x and negative y to see if you get the same thing. And this one, you just plug in negative x. So first, let's plug in negative y. 4 times negative y. Does that equal 5x squared minus 6? No. If you plug in negative y, it does not get you the same thing, so it is not symmetric to the x-axis. If you plug them both in negative, you will not get the same thing either, because that negative y is going to cause us some problems. That'll be negative 4y. This gives me the same thing of 5x squared minus 6, but there's still the negative. If you just plug in the negative x, you get 4y is 5 times negative x squared minus 6. That does give you the same thing of 5x squared minus 6. So it has y-axis symmetry. This one's another graph. On this one, you can plug in y equal negative y to see what you get. X squared plus negative y squared, does that equal 3? Yes, that's x squared plus y squared equals 3. It does have x-axis symmetry. So it's not origin only because it does have x-axis symmetry. So now let's check the y-axis. That would be negative x. Does negative x squared plus y squared equal 3? The answer is yes. X squared plus y squared does equal 3. So it does have y-axis. And to check the origin, you would have to plug both in, negative x squared and negative y squared. And does that simplify out? Yeah, it actually has all of them. We did talk about this earlier. That is the graph of a circle, which does have all the symmetry. Okay, these are just plotting point problems. Those are pretty easy. I'm not going to do those. All right, even, odd, or neither. Even has y-axis symmetry. Odd has origin symmetry. X-axis is not going to be one because that wouldn't be a function. So you're just looking if it has a y-axis or origin here. And if it doesn't, you would say neither. This does have y-axis symmetry, so this is even. This one has origin symmetry. If you flip it upside down, it would give you the same graph. So that is odd. This one looks like it has odd, but this has a solid dot and this has an open dot. So because of that, that is your neither. Okay, you're going to plug these in, or you can look at the graphs on those. On this one, you actually do have to plug in negative x to see. If you plug in negative x and you get the same thing, then we call it even. If you plug in negative x and you get the exact opposite, we're going to call it odd. So 2 times negative x, square root 18 minus negative x to the 4th. This is going to give me a little glitch, is what it's going to give me. Negative 2x in the front, 18 minus an even number of negatives makes that this. This negative in front, because these are being multiplied together, does actually give me the opposite. That is odd. And the reason is, guys, because like if I have 2 square root of 3, its opposite is negative 2 square root of 3 because they're being multiplied together. This just looks complicated, but it's really just one piece. So that is odd. Okay, and this is talking about the shifts. You're going to take the mother function of y equals x, and then the minus 7 is outside parentheses. So that was a down 7. Outside parentheses is a down 7. I told you these would be the easier ones than we're doing on the test, and you would go ahead and graph that, but I'm not going to graph it. You could use your calculator to help you with these too. This time it's taking the graph 1 over x, and it's outside of parentheses again with the minus 3. So that is a down 3. Which one of these moves that graph down 3? You can tell pretty easily that that is B. Okay, remember on these points, this is the direction. Since the 4 is in front of the f of x, that's telling you to take 4 times the y. If they wanted you to do something to the x, they would put it in the parentheses. So I'm going to leave the x the same. So the x is still going to be negative 15. And the only thing I'm going to do is take 4 times the y, which is 4 times 4, and that is 16. So this is one where you do something to the x. You can try that on your own. This time you're going to take the y value and subtract 2. So keep the x the same, and you'll take the 8 minus 2, and that will be 6. I'm just not going to type it in to save me some time here. This time, you're going to take the graph, and you're going to move it up 3, and the negative is in front, so you'll flip it upside down, and you'll find the matching piece. You'll find the right equation. If you flip it across the x-axis, that flips it upside down, a negative in front. Right 9 units is in parentheses, opposite of what you think. So it'll be the minus 9. Okay, that one is very similar. Here's the graph, and they're taking negative 4 times the y. So if you take this point here, and if I take negative 4 times that point, it will flip it down here. So the answer has to be B, because that's where that point has that negative y-intercept. Okay, this time you're going to take 4 times the x value. And if you remember, 4 on the x value is inside, which is opposite of what you think. It's left to right. 4 is big, so it would actually squeeze it like an accordion. And which one of these squeezes it like an accordion? The tail end still has to be tall on the right. That would be C. Okay, we're going to skip that one. Here's another one. This time you're going to go to the right 5 because it's in the parentheses. Opposite of what you think is the right 5. 1/3 is outside of parentheses, so it's up or down what you think, and it's going to squeeze it. So to the right 5 and a squeeze, we'll take that point to the right 5 and make it a little flatter. Looks like my answer is A. Okay, what are they doing here? They're just taking the absolute value of all the y's. So anytime the y is negative, they want it to flip up instead. So all these get to stay where they are, but this just needs to flip up. So the answer will be A. We got to be almost done. Yep. Okay. And this is the new stuff, and we'll wait to do that. So I got through all the test review except the new stuff, and we'll learn the new stuff on Monday, Tuesday, but I might go ahead and post a review video sooner than that in case anybody wants to work ahead.